And next up, we have a talk, really interesting. This is on game delivery. So we have Bill Wohnoutka, who's VP of Global Internet and Content Delivery Services at CenturyLink. He leads a group of product managers, and he's responsible for CenturyLink's internet access, content delivery network, as well as broadcast transport services. And the name of his talk is Game On. So we're really excited to talk about the challenges that you guys rose to in delivering streaming gaming.
Well, thanks for the opportunity to come on and talk about what we did. I'd suggest that many of our peers in the CDN space undertook the same activities and actions that we were asked to. So, as much as this is about what we at CenturyLink needed to do in order to, I think, be good stewards of performance through COVID, it's actions that our top competitors like Akamai and Fastly have taken through that process. Go to the next slide, please. One more. Okay, well, we sort of had a pretty interesting confluence of events here. The gaming industry has been an industry in change for quite some time, and it's no stranger to disruption. And I think the disruption we've seen over the last several years is that free-to-play and free-to-all games have become a very popular way to increase the user base, and then monetization is generally driven through other means rather than having a paywall to enter the game. What changed this year is that these concepts started to enter the business of what I would call very traditional AAA games. And those are games where quite a bit of money is spent on the art and the music and the distribution and the marketing of these games. So AAA games, might be a Call of Duty as an example, or a Grand Theft Auto, for example. One of the things that I think has really changed for the business is that as disruptors have come and launched, free-to-play games and free-to-all games in this space, AAA life cycles themselves can be extended with a simple value proposition, and that offer is free. And so for those of us that have never wanted to, spend the money to get through the paywall, typically about $40 to $50 for a AAA title, this has, created an opportunity for the market to really open up and encourage more game players. In fact, you can imagine a scenario where maybe my best friend and I are saying, hey, I just discovered this game online. We've been wanting to play this for a long time. I want to play against you. Let's go download it, and then we'll play as soon as it's finished downloading. Well, that value proposition diminishes pretty fast if the consumer experience is diminished when free does not equal fast. And even worse, potentially, my best friend may have been left behind and might have gone to join the game to play with some other friends, and that would then start to drive a bit of a relationship issue for us, in that I've picked up and started to play games with another group of people who are able to download it fast enough. And it's kind of a simple analogy, but I think it's it's very real, and it's very real to gamers, and it's very real to consumers that they need to be able to receive content when they're asking for it. Now, a lot of what's happening with game downloads too, to keep in mind, is that there are a number of patches, and the platforms themselves tend to pick up the updates to those games, without human interaction. So there's an element to this that is, let's go get the game and let's play it now. There's also an element to this that there's unmanned, IoTs essentially downloading, a fair amount of the game traffic that we see on a regular basis. So essentially, the global pandemic is, I think we've talked about this ad nauseum, but it's profoundly altered how we work, and it's increased the global economy's dependence on sustaining high levels of internet performance. So if you would go to the next slide, please. My idea of humor here is that when free AAA gaming meets the global pandemic, it's as if an irresistible force. We're meeting an immovable object, and the result is something that I think it's hard and difficult for every network to deal with, whether you're a CDN or an ISP or a transit provider, or you have a different angle on on a private network space that you're trying to manage. If we go to the next slide, please. High peak to mean peak ratios drive what we call regrettable costs. I won't give you the specific time frame here, but you definitely see a COVID curve and you definitely see, sort of the frequency of what large gaming events tend to look like over a period of a couple months. And those large events, tend to happen very infrequently. They become an outlier in your network performance that you need to solve for. Carrying enough headroom to accommodate all of that peak traffic is expensive. And by regrettable, what we mean is that the time in between the peaks, you're not getting the advantages of having spent that money or having put that capacity into place. And so, when you think about the fact that these very, very large game spikes are infrequent, it just makes the problem significantly more difficult to deal with. Certainly is a call out to do something more thoughtful. If you go to the next slide, please. Forward, yeah, thank you. And so governments weren't shy as we went into COVID. They were aware of the risk that large game downloads create for user experience. And a number of regulators, informally or formally, reached out during this period of time to really the full ecosystem of game distributors. So the people who have the platforms and deliver games for game developers. You can think of the large ones being companies like Sony or Microsoft or Electronic Arts or Valve or Activision Blizzard. And the tendency in this space is, to be very marketing led. So as a new game becomes available, the desire to get that game into consumers' hands as quickly as possible is an absolute business driver and business requirement for the revenue side of that business. Similarly, getting patches out quickly and ensuring that players have similar experiences in stable platforms and are able to engage at the same time. These are all really, really highly important aspects of running a game distribution business. And the game developers and the game distributors have long used specific days during the week for large events. And so in the last slide that you saw, you would have noted most likely that the peaks would occur somewhat infrequently, but the big day game download day on the internet tends to be on Tuesday at about 11 p.m. Pacific time. And typically what will happen is those games will be launched across the globe at that time. So as that patch or that new binary is available, it's put into the distribution platform and then pushed out to as many devices and as many users as possible in a single window globally. So what the governments came back and said is, look, where feasible, we should be using off-peak hours to accommodate large downloads. And that should be scheduled from midnight to 8 a.m. And if you're at 11 p.m. on the West Coast of the US, you've probably just about made it out of the primetime window peak for video traffic and OTT and other types of consumer traffic. But you're hitting business hours in Asia Pac, and you're hitting the start of the business day in Europe. So I think the ask here was really start to plan to roll those releases into an off-peak window so that we're not disrupting business hour traffic, which has become so much more important. If that's not impossible, they also asked that we avoid peak times of 5 p.m. to 11 p.m. This would be when I think OTT typically sees its big liftoff every day, locally in each region. And I think that the entertainment and use of the internet for entertainment and for speaking with your family and those things were heavily considered there. The ideas and suggestions about rolling downloads, phasing of downloads, rate limiting and spreading download traffic. I think, I've kind of covered the main, concerns there. Rolling downloads and phasing could absolutely be accomplished, but not without a change in the way that the industry views its opportunity and its need to get content to consumers quickly. So the final piece, advanced warning of significant releases and updates to ensure preparedness. This is a practice that I believe every CDN works with their game download customers to achieve. But even there are times when our customers on the operations side are not necessarily privy to the exact release date or that release data is being treated as confidential and need to know. And so, definitely leaning into an area here where our customers and the people we work with directly may not be privy to the actual dates themselves. So some real challenges in this. I would say, there was a lot of dialogue that was both public and private, and there was a great opportunity to interact with customers and with some of our peers as well. Now, from a COVID standpoint, we absolutely saw the same lift in traffic across our IP backbone that's been described here, about a 30 to 50% lift on daily peak traffic. And we worked very closely with ISPs to ensure that capacity upgrades that were going into place were accelerated, and that where we expected to see traffic congest, that we would pull forward on our planning budgets and co-invest. So we took those actions all across the globe with our ISP partners, and it certainly helped. But again, it's hard to plan for these extreme peak events. So we had to take additional measures, and I'd like you to go to the next slide, please. One more. I'll call this a short-term solution, and apologize here. There's a little bit of a misnomer on this slide. This is really meant to be a kill switch methodology, not a DNS kill switch methodology. But the idea here is that your HTTP servers, or whatever your responding device is going to return 5xx request errors, and that you will use those content not available errors to slow down the rate at which you're passing traffic back to the clients. So there's a real risk here, which is that the clients themselves will build up a very large retry request rate, in addition to the steady state demand, and that could create an even higher demand scenario once you remove the methodology of issuing a percentage of your total traffic of 500 errors. I think the other real problem with this potential methodology here is that it's inelegant, potentially, and would cause unexpected client behaviors that would result in errors. Certainly for any user traffic, that could be a real challenge to user experience, and it could have unexpected consequences on other platform elements, like a set-top box or a gaming console or a PC that's downloading the software. So what I've actually demonstrated in the slide is a use case that we observed in testing. What you see here, and this is testing in live with reduction in traffic. What you see here is a initial peak towards the middle of the slide to the left of the red circle. And then you see the effect of the kill switch on the traffic. So essentially discarding a percentage of traffic to maintain a traffic level that's comfortable, based on the capacity planning that goes into the network and the interconnections and the server side. And as soon as that kill switch is removed, you see that the actual spike that includes demand from clients that have been retrying goes up even higher. So this is I think a fairly crude methodology. We opted to work on a slightly more elegant methodology, and if you would go to the next slide, I'll talk through that one. I call this TCP session rate limiting. It's using TCP max response rates to reduce session throughput for your highest bit rate clients, thereby reducing the overall peak traffic throughput. There's a real risk here that your sessions could stack, and you'd see sort of a similar situation to what you saw on the last slide, where the actual demand from servicing more sessions simultaneously, creates resource consumption challenges in the serving infrastructure. And again, I think this had the potential to have inelegant or unpredictable client behavior, but it had a number of things that were right about it. The first is that in the world of gaming, if any of you have spent any time there at all, from a user standpoint, there's a lot of focus on what's fair, and having an advantage in gaming that you didn't deserve because of your skills or because of your accomplishments is viewed to be pretty negative in that community. We do believe that dropping the top bit rates allows us to have a pretty precise control and targeted decrease of the peak traffic. So if you think of it this way, let's say that the average traffic in Great Britain were 30 megabits per second, and we said we wanted to accomplish a 25% reduction in overall peak traffic. We would then hypothetically go ahead and create a max response rate that would lead to a throughput of 22.5 being the top throughput, and we would essentially drop our top bit rate. What I wanted to show you here and demonstrate, this is real data. I've had to anonymize it pretty significantly. The effect would be on the client behavior in the blue line there. The client is going along swimmingly, getting up to 30 megabits per second, depending on network conditions and other variables in their environment. And that would be, as tested to a specific server asset on the CDN side. And at the point that the throttle would kick in, what you would see is that the bit rate would be capped at 22.5. So there you have sort of an average bit rate of 30 megs. And then for the period of time that the cap is applied, let's say that was during peak hours, during internet usage, or maybe it's not during off-peak, but during business hours. These throttles can be applied and have a really precise effect on exactly how fast the web server would allow the client to receive data. In our case, this required us to do some development, which we were able to do during the period, and able to actually, canary soak that and get confident and comfortable that we were able to deploy with multiple major customers during the event. The net impact of this, however, is observed below from a market behavior standpoint. What I'm demonstrating there is 2 days of peak traffic. And in the line below, there's those two lines there. You see one of the lines is having a much smaller peak. We actually tested this traffic in the market that has the higher peak, and where I've circled in red, you'll observe that those two markets actually came very close together in terms of peak traffic, and we achieved about a 15% improvement at that point. After the two peaks in the middle, you will see that the two markets sort of return to the ratio of traffic that they were each serving before. So on the left, both markets are uncapped. In the middle, one of the markets, the larger of the two, is capped, and the two peaks come much closer together. And then we apply the methodology back to the smaller market, and you see that the ratio stays the same between the two. So if you go to the next slide, please. So just kind of a quick summary from our perspective. There's two viable methodologies here, and CDNs and ISPs tend to be belt and suspenders guys. I would say that the TCP session rate limiting allowed us to use very gentle and non-user observed condition that effectively gave us a very fine control over how much traffic one of our gaming customers would want to send. So they were able to tell us, this is where I want to be in this market, either on a throughput standpoint or peak standpoint. And given the Lewis scripting nature of our edge, we were able to just go ahead and set up rules that allowed us to apply those rules whenever the customer would want to have them implemented. Now, I'll say not every customer wanted to do these things the same way or felt the same about every market, but it certainly was simple for them to use. There was no development required on their side. From my standpoint, the effectiveness was high. We saw incredibly tight tolerances to the targets that we set once we had kind of vetted the hypothesis. And the network risk was low. We were essentially, I think, very worried at the beginning, but after several days of canary soaking and going fairly slow and watching under conditions that were changing constantly, came to the conclusion that this wasn't creating CPU bottlenecking or any of the other server resources that might have been congested by trying to tie up more resources. Ultimately, again, this is the kill switch. The 500 errors are essentially what we're talking about here, just to avoid any confusion. Time to effect is typically was on the order of about 15 minutes. So if you wanted to make a change immediately, it wasn't an easy thing to do. You needed to be a bit ahead of it. There was observed user experience issues I think, again, this was a very simple thing for customers to use, but the effectiveness was essentially only medium. To a large extent, you really can't control how much traffic you're receiving as a CDN serving for a customer. And so there's always this risk that the demand is infinite and you're eventually going to run out of resources. And I think that this methodology creates a little more risk there. It's just a little less elegant, and then it does present a higher network risk. So at the end of the day, we've actually adopted both methodologies, but the TCP session rate limiting is the one that we feel has the best results for the customer. And then I think you would keep a kill switch in place in case you had a very dark day on the internet. You do have some additional tools in your bag. I had just a couple more comments. These were short-term solutions for us. If you could go forward to the next slide. We have been working on a long-term solution, and this is something that you may have seen. We announced that we acquired StreamRoot in 2019. They are a peer-assisted mesh delivery company. So they specifically work with CDNs, and it is an open CDN technology. They work with all CDNs, not just ours. So they've worked very hard to be, I think, easy for a customer to integrate with CDN and any multi-CDN strategy they have. Peer Assist has started to gain traction in the video space, in particular in Europe, where we've got several announced large customers that are, fairly popular regional broadcasters for that area. What we've seen over time is that hybrid CDN and Peer Assist can deliver elastic scale. That's not possible by just using the physical assets in a north-south relationship between a CDN and an ISP. And that they're also incredibly effective at improving user experience metrics for hard-to-reach geographies, and effective routing for ISPs to manage it. The technology takes more advantage of the east-west capacity that's available downstream in the ISP's network, and generally speaking, we've received very positive feedback from ISPs that this technology is enabling them to avoid those regrettable upgrades that we showed on the first slide. So I've got a little bit of data to just kind of back that up here. If you would go to the next slide, please. In a mesh delivery use case, and this is a real customer's traffic. Here's a large-sized broadcaster in Europe with traffic identified during COVID period. This is specifically during the French president's address to the nation regarding the stay-at-home orders. And during the spike in traffic, we were able to achieve a 70% east-west offload, if you will. So peer-assisted offload, where the devices that our customers have their players running and where they've taken our code and put it in their players, those devices were able to offload the north-south traffic, which is what you see in red, which is CDN to ISP traffic. We're able to offload that and serve more of it from within the ISP's borders. So less dependency on interconnection and peering. And again, for an event that was essentially 3 times the 95th percentile. So if you look at the second slide on the number of users that were simultaneously viewing the event, you'll see that not just the peak to mean peak, but the peak to 95th percentile was 300% here. That's just not something any ISP can afford to plan for. And so, given the importance of this communication to the nation, we felt like this is technology that really enabled a better way for the government to communicate with the citizens. And what you see at the bottom there is the change in buffer rates. And so I guess the irony in all of this is that at the highest spike that we saw with this particular customer during this period of time, they were actually achieving the best and lowest rebuffer rates that they measure. So if you think about it, it makes a little bit of sense. The more peak concurrency there is for a object or a video or a piece of software, the more devices there are that are trying to retrieve that, the more those devices can be efficient and download less of the traffic from north-south and increase the amount of traffic that goes east-west inside of the ISP's backbone behind the peering. I guess the final slide here and the punchline for me, if you go one further, is that when we acquired StreamRoot, the first thing that I worked on with the founders, Pierre-Louis and the team over there, was to ensure that we had the right number of software developers in the business case. And we really focused on the idea that gaming was, if not as important, a market to put this technology into, that the technology would have to be customized. So we've accelerated our game downloader development, and that will include an off-the-shelf download manager that a gaming company could deploy, and an SDK inside of that downloader. All of this is being ported into C++, and we're working on making these libraries available on the native platforms as well, so that developers can find these APIs and find this capability within platform devices themselves. So I'm anticipating a release of the product offering in 2021, but we think that it's going to be a very, very hopeful software trick to add to the mix here. And we'll be spending a lot of time working with the downstream ISPs and with our peers to ensure that they understand what the technology is, and ultimately allowing them to customize traffic flows between peers within their network. So ensuring that they have fine-grained controls on an IP prefix layer, so that they're able to actually guide the traffic within their network themselves, and have the ability to influence which peers serve across which IP prefixes. So that's kind of the end of my discussion here. But it's been crazy time. We've seen a lot of great cooperation between customers and ISPs and our partners. And just want to thank Thousand Eyes for having us on today.
Thank you so much, Bill, for being there. It's funny, like, you think everything works, so it's so nice to kind of hear behind the scenes what happens. So thanks for sharing that. I just think the DNS skill switch that you mentioned, so not a misnomer. So it's kind of funny and interesting. So thank you